All right, so on the test, I'm going to say something like, show that the current through the 8 ohm resistor is approximately 1 amp. Okay, so I'm going to throw you a bone like that. But here I didn't do that because I didn't feel like that. Yeah, so this is Kirchhoff's laws, right? So it's gonna say using Kirchhoff's laws show that the blah blah blah, right? Okay, so you could go. That could be I1 flows into this junction, right? I2 also flows into that junction. We could have I3. It seems reasonable that I3 would flow that way, right? Right. So our first equation, and there's four marks, right? The last one is for obviously getting the right answers. But if you show your equations, you definitely get some points here, right? So we would say I1 plus I2 flowing in equals I3, or if we're matrixing, right, we'd say I1 plus I2 minus I3 is 0. This is what I do. I just kind of draw a box around it. Okay, the next one would be, let's do a loop on this side here. I just going to do right side and left side, like I always do. So we got negative 6I1, and now we're going this way through this guy, right? So notice we're going downstream, that's why it's negative. Going the correct way through the battery, so we go up 12. Right, okay. And now we're going upstream I2, right? So plus 8I2. And we're going the wrong way through the battery. Like, whoa, wrong way. So minus 22. And then we're back, right? We're back to there. So that's 0. Let's just double check that. Down 6, yep. Up 12. Up 8I2. Down 22, right? And then this becomes negative 6I1 plus 8I2. And then if we put all this on this side, we've got 22 and negative 12. Why am I doing that on the calculator? That's 10, right? And then we have 0I3. So I always write the formulas in matrixable formation, right? And then let's do a little whoopie-doo here on this thing. I'm going to start here. I'm going to say negative 17I3. I'm going now the proper way through that battery. So plus 22 minus 8I2. And I'm home. I'm back on the same piece of wire, right? So let's double check that. Down 17I3 because we're going downstream, right? Energy is being used up, and that's why it's negative, right? Okay. Oop, we're getting energy added, so it's plus 22, right? Oh, we're going downstream again. Okay, and now we can just plug this in. So we got 0I1 plus negative 8I2 plus negative 17I3 is negative 22. Is that right? There we go. So my matrix looks like this: 1, 1, negative 1, right? Negative 6, 8, 0, 0, negative 8, negative 17. And then that times, we got 0, 10, negative 22. That's going to equal I1, I2. Let's see if it actually works. I don't want to, I don't want to post a video. It's gonna that's all wrong. Okay, what did I just do? I went somewhere I shouldn't have gone on my calculator. Willing to accept that. 1, 1, negative 1, 8, negative 6, 0. Okay, let's see. Okay, did I do that right? Betty boop, I did. All right, so let's see. Doodly doo. Oh, dang it. What am I doing? All right. I need like an escape key. Oh, I see what I'm doing. I'm doing second instead of alpha. Okay, 3 rows, 1 column, I feel like is what we need next. Oh no. No. All right. Okay. Sorry about this. Yarbly. Okay. I tell you what, I'm just going to keep going here. I'm pretty sure that's the right matrix. Now, it says, what's the potential difference between x and y? So find that one. That one's got I1 through it, right? Okay, so you're going to take this current, right, through the 6 ohm resistor. Notice that it's actually going down in this case. You'll get a negative number when you do that, okay? And so this thing's actually going down the page, even though we predicted it was going up, but you'll get, when you do the matrix, you'll get a negative number, okay? And so the current is actually flowing this way. Okay, it's actually flowing that way, right? So how do you find the voltage from x to y? You're just going to go V as IR, right? And I is going to be 0.259, right, flowing down the page. And then R is going to be 6, right? So just plug that in. Okay, you're going to get the right answer. And then the question is, so 6 times 0.259 is, yeah, there we go, approximately, right? Okay, and then the question is, which one is more positive, X or Y? Well, if the current's flowing this way, remember it loses energy as it goes this way. So Y is going to be more positive because the current's flowing that way. And X will be more negative. And that's just simply because the voltage is dropping. And the reason it drops is that the energy is getting actually turning into heat. These resistors heat up. It's losing energy, okay? And you'll have to explain that. You'll have to not only state which one it is, but you'll have to say something like, because the voltage drops as it goes through the resistor because it loses energy. Anyway, good luck on that one.